Hello everyone, we want to continue on the topic of capillary pressure. We derived the equation for this system, which was Pc equal to density difference of water and oil multiplied by the height of the water in the capillary multiplied by the gravitational acceleration. However, this equation is for a system that system of units, which is SI unit. So in this equation you have to use kilopascal for, or Pascal basically. You have to use Pascal for pressure, kilogram per cubic meter for both densities, and meter for the height, and G is 9.8, right? Meter per square second. Now, in petroleum engineering, we use the field units, however. So we need to use another system of units, which is the field units. And in that case, the pressure in the field units, if you remember, we have already talked about this. PC, or pressure, should be in PSI. Height should be in feet. And then density is also pound per cubic feet. So in order to use this set of unit, we need to use conversion factors because the system of the units in petroleum engineering, which is field units, is not consistent. So in that case, our equations become rho W minus rho O multiplied by the height divided by 144. So in this case, your pressure is in PSI. The density is going to be pound per cubic feet again, and height is going to be in feet. Okay, so that's the system of the unit that we have to use in this case. And you can see that this equation again, the capillary pressure is a function of the density difference between two phases and the height, or you can say that the height of the water in the capillary tube is a function of the capillary pressure and the density difference between two phases, right? So we have this equation, we found this equation, and in petroleum engineering, we define also the capillary pressure as well. So in petroleum engineering, usually we have a bedding phase, which is water. So if we define the capillary pressure, which is the P non-bedding minus P bedding, then the P bedding is equal to P water, because the water is the bedding phase most of the cases, and the oil pressure is the non-bedding phase pressure. So that's how we define the capillary pressure. If you have a water gas system or oil gas system, the gas is always the non-bedding phase. So in that case, you define the capillary pressure as P gas minus P water if you have a gas water system, or you define PC is equal to P oil minus P water if you have a oil water system. All right, so we will continue on this topic. This was a short video, and I'm gonna talk about how we apply the capillary pressure in petroleum engineering and why is it important for us in next videos.